Alright, I'm going to help you understand this confusing topic in calculus. Well, here's the deal. We are given three exact same picture, but they represent different things. For the first one, this is the original function f. And for the second one, this is the derivative of f. And for the third one, we have the second derivative of f. And the question is all asking us to find the point of inflection of the original. And we just have to give the x value. Let's focus on the first one right here. So if we are given the original graph and we are trying to find the point of inflection, what you see is what you get. This right here is just that, I will just write this down, f changes from concave up to concave down, or the other way around, concave down to concave up, one way or the other. As we can see, this is concave down and then this is concave up. So we have a first point of inflection right here, and then from here to here is concave up and then concave down. So we have a second point of inflection here. So that's going to be as 3 and 5. So we have 2 points of inflections, 3 and 5. Done. What you see is what you get if you are given the original graph. Now, next it gets trickier because we are given f prime, which is just the first derivative, and we have to answer the question regarding the original function f. So how can we do it? Well, the quick way to do it is, if you want the POI of f, this right here is actually just a local min or max of the derivative graph. And as we can see, we have a local max here, local min right here, and a local max here. So we have 3 of them. X equals 2, 4, and 6. And then we are done. Now, let's think about why is that the case. Because remember, the point of inflection of f is always going to be where the second derivative changes signs. So I will write this down right here for you guys. Point of inflection of f is where f double prime changes signs. So it can go from positive to negative or negative to positive. And we are given the first derivative already. So how can we do the second derivative from the first derivative from the graph? Well, we look for the slope. So as you can see, if you put a point right here, you see, you do the tangent segment, the slope right here is positive. Well, the graph represents f prime, right? And then when you do the slope, you have positive. So that gives you the second derivative. And you are saying that the second derivative of the original is positive. Right here, the graph represents the first derivative. And when you do the slope like this, you are doing the derivative of that, which gives you the second derivative, and the second derivative of the original is 0 there. And if you pick a point right here and look for the slope, f prime, because that's the graph, and then when you do the tangent segment, you are doing the derivative of that, and we know the slope right here is negative because it's going downward. You see? The second derivative goes from positive to 0 and to negative. So here will give you a point of inflection of the original. Similar to here and also here. Alright? Now, if we have the second derivative and we have to answer where is the point of inflection of the original. So what do we do in this case? You want to think about it? Remember, it's always going to be where our second derivative changes signs. Alright? It can go from negative to positive or positive to negative. Look, we have the second derivative graph already. So in this case, it means that we are looking for the places where the second derivative goes from below the x-axis to above, which is just like a flying fish going out of the water like this. So that's one place right here, 1. Or going diving, right? Diving to the water from above to below. This right here does not count. it's not changing sign, right? So we only have two of them, 1 and 7. All right? So this is x equals 1 and 7. All right? So make sure you study these three examples really well. It's a classic trick equation, but once you understand the concepts, they are the easy ones because you don't have to do any algebras. All right, that's it.